Hello again. This is the next module for week 12. I'm going to do regression testing today. So this is again one of the modules that came as requests from the takers of the course. So what is an overview of today's lecture? I'll introduce you to what is regression testing, give an overview of it. And then one of the biggest problems with regression testing is how to select a set of test cases that is apt for regression testing. So what is apt depends on what are you regression testing, what is the problem that you're trying to solve, and what will be an ideal set of test cases that I can use for regression testing. That problem is the problem of regression test selection. There are several known techniques for regression test selection because this is one of the important problems. So we'll spend a little while understanding an overview. I'll give you a survey of 5 different techniques for regression test selection. And I'll end, as we did for the other 2 modules, by giving you an idea of some of the tools that I'm familiar with to do regression testing. So what is regression testing? Throughout in this course, we have seen testing as it applies in the software development lifecycle. That is, while the software is being developed, we do testing, unit testing, integration testing at the software level, at the hardware level, system testing, acceptance testing, and so on. Regression testing comes after all this. This comes after the software is released and is being maintained. Usually, it's very rare that a piece of software is released and forgotten about. People release it and also maintain a software. Maintenance of a software involves periodic upgrades that are done to a software. Upgrades because some user or customer wanted a change in the software, in some functionality of a software, or upgrades or changes because there was an error found in the software after release. Lot of companies usually develop software that lasts for many years. In fact, in some kind of fields like aerospace and other safety critical system, a software is developed to run for many decades, that is tens of years, 20 years, 30 years, 40 years. Same holds for traditional things like banking software. Software that was written in 70s and 80s using a programming language like COBOL is still being maintained by several IT companies. How do they do it? They have a team that maintains the software, that takes requests for changes, observes errors, writes new code in the language that the software supports, and along with writing new code, the team also has to test whether the new code is working fine or not. Such a test that is done by a maintenance team that maintains a software is what is called regression testing. So, regression testing is a process of validating or testing the modified software. It usually focuses on the piece of software that is modified around the piece of software. A whole software along with the modified component is rarely tested all over again. Obviously, the whole software is put together with the modified software, but the testing focuses on the modifications done and not on repeating the entire set of tests that the old software was subject to. So, regression testing is the process of validating or testing the modified software. The goal is to be able to detect whether new errors have been introduced, in the modified software, and because of the modified software, have new errors been introduced in previously tested and released code. Regression testing is also meant to provide confidence that the modifications done are correct. It is typically considered a black box testing technique and is typically very expensive. Why is it very expensive? It's expensive because people have no idea or clarity about how to select a set of test cases to do regression testing. We'll spend some time understanding it. So is it clear, please, what regression testing is? A software is being maintained, and in the process of maintaining a software, people make periodic changes to the code. The change that is made to the code is tested to see if it has no errors. If the changed code doesn't result in any errors in existing software, and to gain confidence in the changed modification. Typically, what is the process for regression testing? Let's consider P to be a procedure or a program, and let P prime be a modified version of P, the changed version of P, and let T be a test suite for P. P was a program that was developed, tested, and released. being maintained. While being maintained, it was modified to obtain P prime. Now, we already have a test suite that was tested for P and documented and stored aside for use during modifications, if any, happens. So regression test process proceeds for P prime as follows. So from the set T prime, which is a set of test cases for P, we select a subset T prime, which is a subset of T, which is a set of test cases to execute on the modified version of P. This is a very difficult process. We'll spend some time on how to select this T prime. Once you've selected T prime, what we do is we test the modified P prime with T prime, establishing P prime's correctness with reference to T prime. If there is an error, of course, it goes through the natural course. Sometimes in regression testing, we also create a new set of functional or structural test cases for the modified version P prime. In addition to T prime, we create a new set T double prime, which is exclusively meant to test the modified version P prime. Then once we create it, we test P prime with T double prime, showing that P prime is correct with reference to the set of test cases T double prime. Then for now, P is no longer exists. P prime is the one that's modified version of P, which is going to be integrated into the software and kept. Now later, P prime might be modified, a portion of P prime might be modified. So you might want to document and record a set of test cases to be used when P prime is modified. That's the last step. So a new set of test cases T triple prime is created from T prime and T double prime and kept as a record as a test suite and a test execution profile to be used for P prime. So just to succinctly repeat what I said, we have a procedure or a program P that's modified to P prime. There is a set of available test cases T for P. P prime is tested with a subset from T. P prime is tested and P prime is also tested with a new set of test cases T double prime. And P prime is tested with T triple prime, which is kept, which is derived from T and T double prime and T prime, and kept as a record for the set of test cases to be used in case P prime is modified. So there are 5 steps that we understood here. Each step deals with a different problem when it comes to regression testing. So step 1, which is the selecting T prime, which is a subset of T, is called the regression test selection problem. It is the problem of selecting a subset T prime of T with which P prime is tested. Step 3, which is T double prime, which is a new set of functional test cases, is done because sometimes T prime may not cover P prime. So step 3 addresses the coverage identification problem, that is, the problem of identifying portions of P prime or the specification of P prime that require additional testing. Steps 2 and 4 basically are execution, test case execution. So it is that a set of test suites are selected, they are executed. So the steps 2 and 4 talk about the test suite execution problem. That is the problem of efficiently executing test suite and checking the results for correction. Steps 2 and 4 can be fairly largely automated, like in other cases of testing, because it's just test case execution. It doesn't need much of algorithmic knowledge, but needs extensive tool support. Step 5 is the part where a set of test cases are kept aside to be used for P prime if required later. So step 5 addresses the test suite maintenance problem, that is the problem of updating and storing test information. What we will be spending in this lecture is I'll tell you some techniques for regression test selection problem, which is step 1, and I'll also tell you some tools that help you in test suite execution, which is regression testing automation. Before we move on, just a small point about regression and specifications. Regression test selection is applicable both in cases where specifications have changed and specifications have not changed. When do I do regression testing when specifications have not changed? Maybe I found an error in the software that is released, so I can develop a patch that rectifies the error, and regression testing is done for that. If this is the case, then it means that the specifications have not changed. I am doing regression testing because I found an error. So in the case where the specifications have changed, we have to identify test cases that are obsolete for P prime prior to performing test case selection. So what do we mean by test cases that are obsolete? They are obsolete for P prime if The test case specifies an input to P prime that is invalid for P prime. It means the format of the input, the syntax of the input, the type of the input doesn't match P prime. P prime cannot even be executed on that input. Or the test case specifies an invalid input-output relation for P prime. So once we identify these test cases that are obsolete, our goal is to remove them from T and then do regression test selection on the remaining test cases. So test selection process, we don't worry about identifying obsolete test cases. So now coming to regression test selection problem, here is an overview of what happens while selecting regression tests. Regression test selection requires obviously knowledge about the system, which could mean domain knowledge, and how the modified code affects the existing functionalities, without which we can't effectively test the code. Tests are selected based on the area of frequent defects. Where do the defects happen? The Pareto principle, which says 80% of the defects occur in 20% of the software, applies to regression testing also. And tests are also selected to include the area which has undergone code change many times, because that's where the problems, if any, are likely to occur. And tests are also selected based on the criticality of features. Let's say you've changed code because you wanted to cater to a particular feature which is highly critical, then you focus on regression testing for that feature. You could do any of these. So we'll walk through a set of 5 different techniques for regression test selection. Towards the end of this lecture, I'll point you to a reference to a survey paper, which is slightly old but still very relevant in terms of its use, which talks about all these test selection techniques that we have learned, and the papers that I'll be referring to. All of them are referred to or cited in the survey. So the first set of techniques are called minimization techniques. What do? They attempt to select minimal set of test cases from the set T that yield the coverage or modified affected portions of P. Minimal means minimal in number of test cases is as less as possible. So the subset T prime that you choose from T is as minimal as possible. Usually this problem is undecidable in its most generic case. I don't know what is a minimal set of test cases, but for these kind of programs or procedures that are basically one block of statements, a sequence of statements with a single entry and a single exit, meaning there's no branching, no looping, etc. There are some solutions based on 0-1 integer programming techniques that do minimization test case selection for regression testing. As I told you, the survey paper that I will be referring to towards the end of this lecture will point you to more references if you're interested in knowing about it. The next is Dataflow techniques. Dataflow coverage based regression test selection. They select test cases that exercise definitions in use or data interactions that have been affected by the modified portion. Here is one paper, slightly old but again a very good paper. It's a technique by Harold and Sofa, which requires that what sort of data interaction is tested here? Every pair of definition and use that is deleted from P, or is newly added in P prime, or is modified for P prime is tested. So this technique basically selects a test case T in T such that when it is executed on P, it is exercised, deleted or modified definition use pair, or executed on a statement containing a modified predicate. So it tracks values of data definitions and uses that have changed from P to P prime and develops a set of test cases that basically cater to these changes of definitions and uses. The next set of regression test techniques are what are called safe techniques. So we'll understand what is safe technique and what is not safe regression testing. A set of regression test techniques are considered not safe if they fail to detect a test case that would have revealed a fault in the modified test program. Obviously, this is something that we will not desire when we do regression test selection. We want it to be safe in the sense that if there is a fault that is present, it is always detected by the set of test cases that I define. So, an explicit set of safety conditions can be satisfied. A safe regression test selection technique guarantees that the subset T prime that I chose contains all the faults contains a set of test cases that can reveal all the faults that are present in P prime. Again, it's quite difficult to in general guarantee that I will always be able to define a set of test cases that will detect the faults in P prime, but we can try and do our best, and this is a paper that does a good attempt. So here is a paper that basically comes up with a control flow graph representations of P and P prime, and what it does is that it takes the test execution profiles of T being executed on P, and then it says which was at least one statement that was exercised which was actually deleted from P, or the statement when executed on P prime will exercise one statement which is new in P prime. So basically what it does is that it pulls out a set of test cases which make sure that if executed, the execution behavior of P prime is different from that of P. So these set of test cases exercise statements that were deleted from P to get P prime, or set of statements that were modified in P to get P prime, and so on. If you do this, then they believe that you're guaranteed to obtain a safe set of regression test techniques which will find a fault in P prime if it exists, because basically what it tries to do is it tries to cover all the modifications that were done to P to obtain P prime. The next two selection techniques have no great technical depth in them, but are the most used in industry, ironically. So what does this one do? This one basically is called a random test selection technique. It randomly chooses a subset T prime of T and tests P prime from it. Obviously, because it's randomly chosen, there is no basis, no coverage, and no guarantee that the faults, if present in P prime, will be adopted. But it's a fairly standard practice in industry because there is no time to do regression testing. So people just randomly select and do a set of test cases. The next is what is called Retest-All, which is basically take all the test cases that were there in the original set T and test P prime from it. This is obviously safe because it tests the whole thing again, but it may not be efficient because it can be very time consuming, and you might have to write some new test cases that are specific to changes done in P prime. If you just blindly reuse the set of test cases that we are using for P, it may or may not be effective for testing P prime. So we learned 5 techniques to summarize. Minimization, which selects a minimal set of test cases for regression testing. Dataflow techniques, which select a set of test cases that basically ensure that for every variable that is changed in P prime, its definition and use are tracked. Safe techniques, which basically ensure that faults, if present in P prime, are revealed because it selects a set of test cases which either modify or delete a statement in P to obtain P prime. Random, which is basically a random selection of test cases T prime to execute on P prime. And Retest-All is execute every test case on P that was present in P prime. So these are 5 techniques that are known for test case selection. I'll point you to a survey paper from which you can learn more about these techniques and also get data to the exact papers that we refer to while giving an overview of these techniques. Moving on, now different regression test selection techniques can create trade-offs between the costs of selecting and executing test cases. Obviously, because based on what your priority is, you need to select test cases accordingly. It's been found through empirical studies that the choice of the test selection algorithm significantly affects the total cost of the regression testing. So when it comes to automation of regression testing, like all other testing, this is heavily automated, cannot be manually done always, especially the execution part of regression testing. So typically the previously executed test cases or the newly selected test cases are again run on a new build that is created for regression testing. They are basically record and playback type of tools, which means what happens there? Test cases are recorded by navigating through the program under test, and they are verified whether the expected results are coming or not. So here are some of the regression testing tools that I have seen. The first one, none of them are open source, all of them are proprietary. The first one is called Regression Tester. It is available from this website. It's a pretty decent tool that exclusively focuses on this record and playback type of execution. Then there is one more called Time Shift X, which basically tries to, typically when you record a test case, you'll also timestamp it and record. So this works by telling that you re-execute those set of test cases by shifting shifting the timestamp in which it was recorded. The build is created just by basically manipulating that. The next is a set of tools from Micro Focus. There are 2-3 tools that do regression testing of some very old code like COBOL programs and all that stuff. You can refer to that tool from this website, Micro Focus. Please remember that none of them are open source. I'm not aware of very good open source regression testing tools. All of them are proprietary. So to end with, here is the reference that I told you. It's a 2001 survey paper which talks about an empirical study of regression test selection techniques. So it focuses on the 5 techniques that we learnt about and tells you how to trade off and how to choose the best test selection problem. And some of the tools I've already given the link provided. Please note that these URLs were valid as of this presentation. So that gives you us an overview of regression testing. And it pretty much brings us to the end of this course. Feel free to ping me in the forum if you have any doubts for the exam. It was a pleasure interacting with all of you. Thank you.